Two carts, A and B, are moving toward each other on a frictionless horizontal track. Cart A is initially moving toward the right at twice the speed of cart B, which is initially moving toward the left, and both carts have the same kinetic energy. Part A, which cart has the greater magnitude of momentum, or do they have the same magnitude? Now, if you jump into this problem too quick, you might be tempted to say that this cart has the greater momentum simply because it has a greater speed than this cart, since momentum is just m times v. But you have to realize that we don't know yet about the masses of the carts, but we do know that the two carts have the same kinetic energy. So if we say the kinetic energy of cart A is equal to the kinetic energy of cart B, think about how the masses would have to compare. If the two carts had the same mass, then cart A would have 4 times the kinetic energy, because the formula for kinetic energy, as you know, is K is equal to 1/2 mv squared. So with twice the velocity, and that velocity being squared, ends up being, with proportional reasoning, 4 times as much kinetic energy. So if the two carts have the same mass, this has 4 times as much kinetic energy. That means since they have the same kinetic energy, this cart over here, cart B, should have 4 times the mass of cart A. So if we say cart A, let's just say it has a mass m, cart B then has a mass of 4m. If you didn't follow that kind of more verbal explanation and you want to actually see this written out fully in equations, it's going to look something like this. We go back to that first thing we said, which is the Ka equals Kb, and then we write down 1/2 ma va squared equals 1/2 mb vb squared. And we know that Va is equal to twice the velocity of Vb. So if we call the cart over here Vb, then Va is equal to 2 times Vb. So we'll take this Va in this equation right here and plug in a 2Vb. But first, just to make things simpler, let me cross out the 1/2s on both sides. So now we have Ma times, and in place of that Va, I'm putting the 2Vb squared equals Mb Vb squared. So we have Ma, 2 squared gives you 4, and then Vb squared is equal to Mb Vb squared. Now I have a Vb squared on both sides, which cancels out, and look what you're left with. You have Mb, the mass of cart B, equals 4 times the mass of cart A. Mass B is 4 times mass A, which is what we said. This cart has 4 times the mass of this cart. So to say which one has the greater momentum, since momentum is just equal to m times v, if we look at cart A is going to have twice the velocity, but cart B has 4 times the mass. So the 4 times the mass would override that twice the velocity that cart A has, so cart B has the greater magnitude of momentum. Part B. When the two carts collide, they stick together. Indicate whether the carts remain at rest, move to the left, or move to the right after the collision. So we just said that cart B has the greater magnitude of momentum than cart A, which means that the overall momentum of this whole system is directed in the direction of cart B, to the left, before the collision. So since momentum is conserved in any type of collision, that means after the collision, when they're stuck together, the momentum of the whole system would still be directed to the left. So part B is a pretty simple one to explain. It's going to the left because the overall direction of the momentum, the total momentum before the collision, is to the left, so the overall momentum after the collision should still be to the left. Part C. Which cart exerts a greater magnitude of impulse on the other cart, or do they exert the same magnitude of impulse on each other? So remember, impulse was given as a capital J, and there was two ways that we defined impulse. One is the change in momentum, and the other way was the force multiplied by the time. The force acting on something multiplied by the time that force acts on it. So we know what the momentum of the carts are before the collision. You could go ahead and calculate the momentum after the collision and then solve for the delta P that way, but there's a much simpler way to answer this question if we focus on the other definition of F times T. Because if you think about it, when these two carts collide, they exert a force on each other. And which of those two forces is greater? The force that cart A exerts on cart B, or the force that cart B exerts on cart A? Keeping in mind that cart B has 4 times the mass. Well, the fact that it has 4 times the mass is irrelevant. If two objects exert a force on each other, those forces are equal and opposite from Newton's third law. So according to this so far, the net force, or the force that each cart exerts on each other, is going to be the same. Now let's look at the time that they're in contact for. Well, you can't have one cart touching the other cart for more time than the other cart touches the first cart. That just wouldn't make sense. If the two carts are touching each other, they're touching each other for the same amount of time. So the two carts have the same force and the same time. Therefore, they exert the exact same impulse on each other. Okay, part D. If both carts had achieved their initial speeds by rolling down a frictionless ramp on either end of the straight track, so in other words, it looks a little bit something like this. We have a ramp where that cart started, and we have another ramp on this side where this cart started. Which cart must have been released from a greater height, or were they released from the same height? Well, we know that the kinetic energies of both carts were the same. Ka is the same as Kb at the bottom, so those kinetic energies must have come from the gravitational energy of the cart. So this cart had a gravitational energy UA, and this cart had a gravitational energy UB. And since the kinetic energies were equal to each other, that means that those gravitational energies must also be equal. UA is equal to UB. Does that mean they were released from the same height? Well, don't jump to that again, because there's one thing you got to remember. The formula for gravitational energy is mgh. And one of the carts had 4 times the mass of the other cart. Cart B had a mass of 4m. Cart A had a mass of just m. So if they have the same gravitational energy at the top of the ramps, the one with 4 times the mass should have been released from a lower height, because to compensate, the other cart should have had 4 times the height. So cart A was released from 4 times the height of cart B. If you want to see this one written out in those equations, kind of like I did for part A, we can say that UA equals UB, that is MA times G times HA is equal to MB times G times HB. We have a G on both sides, which is the same. Those cancel out. We know that MB, if you look back here, MB is 4 times MA. So I'm going to replace this MB with a 4MA. And what that leaves you with now is MAHA is equal to, remember we're replacing this MB with a 4MA HB. Now we have an MA on both sides, which cancels out, and what you're left with is HA, the height of cart A, equals 4 times the height of cart B. So that means that cart A was released from a greater height.